Hello. Okay, I'm glad you're here.
Hello, everyone. Let me turn this camera on. How's everyone doing today?
Well, I guess that's directed to me. I'm good. Great, man. Wonderful.
That's good
Very
to
excited.
hear.
Is this the command center here? This is the Manifold main room.
This is the Manifold main room. Okay, there we go. All right, so we got the screen share working and everything like that, except for some reason it's showing this top bar. All right, so howdy, everyone. Good to be here with everyone today. It's been a very productive quarter for the Manifold team. We're very excited to share our work from the previous quarter. We performed a brand redesign, which you can see right here in the chat, being loved by the community. And I think the best place to start, was Sybil. So this is our hybrid search engine. It is a model agnostic search engine. So now with the new brand update that we've enabled, you can change which model that you're inferencing from. And we've also added performance improvements so that the page load time or the search load time is much quicker. And hopefully you guys really like the new upgrade on Sybil. We're going to be doing a lot of work this quarter on Sybil as well, introducing a lot more features today, or in this quarter, I mean, and particularly around what we're doing on TVM, and that we'll be getting to shortly. I'm going to be spending a lot of this time, like in the novelty search, actually explaining one of the new ways that we're going to be able to use TVM. But more on that in a little bit. The next up is Tao.xyz. Our goal was to make a Bloomberg terminal for monitoring the Bittensor blockchain. So one of the real goals that we wanted to accomplish with Tao.xyz is to replace a lot of the scripts that we use already. So an example of something that we use is, like we watch all of the pending extrinsics, we watch the mempool, we, track different wallets and add tags to them. And so we wanted to make Tao.xyz a place that I could just, like, when I wake up in the morning, the very first thing that I do is I check, the BTCLI ST list. And so now I don't have to open up my laptop and check 3 different places and do all these different things. We can just do it from one place in Tao.xyz. Going along with this, though, a lot of people that we saw that were using existing wallets out there were unhappy with the experiences that they were having. And so we thought this would be a really great opportunity to create the Tao.xyz wallet. And this has native integration. It uses Polkadot.js. So anywhere that you want to, or any place that you're using a Polkadot.js compatible wallet right now, you can use Tao.xyz. And one of the really cool things is that it works on Chrome and Firefox. So if you are using a Chromium-based browser like Arc, I use a lot of Arc right now. It works with that, but it also works on Firefox-based extensions or browsers. And so we're really excited with the team that built this, and really proud of them. It's something that's actually kind of cool that I'll share with y'all, is that on the Tao.xyz main website, we can tell that the bounce rate, for example, is at 1%. The average session duration, is around 10 minutes, which is the best that we've ever had on a particular app. And so, we're very, very happy with the team and everything that we accomplished on that front. Next up is Targon. And when we first started building on Bittensor, I would say that developing websites and these sorts of things and making them beautiful definitely wasn't our strong point. We were much more technical. We were really great at building, server-based applications, CLI-based applications. And so we're really happy with the redesign of Targon.com, which you can check out right now. That just dropped an hour ago. It is something that it's been a long time coming on Targon.com, and so we're very thrilled to be able to share this with y'all. And I would say that the biggest thing, the most productive thing that we were able to accomplish this last quarter was the Targon virtual machine. So I'm just going to put this graph up here. This is in the white paper. It's kind of a high-level overview of exactly how everything works. But the Targon virtual machine is a secure, confidential computing platform designed for AI workloads. It leverages both TEEs on the CPU side and NVIDIA confidential compute to ensure privacy and integrity. One of the really big key things on this is that if you implement TEEs in your subnet, which I think every subnet should try to implement this, whether you're using CPU or GPU, if you are using GPUs on your subnet and you implement TEE but don't do NVIDIA confidential compute, you can do a man-in-the-middle attack in between the CPU and GPU processes to be able to intercept and receive the information that's flowing between the two. And so this is why it was really critical for us to be able to do both of these. It's a lot harder to do NVIDIA confidential compute than, just enabling secure boot in the BIOS. But we've made the install process very simple. It's the easiest it's ever been to set up a node on Bittensor or on Subnet 4. And so this is going to enable us to do all different sorts of workloads, training, inference, and it's fully confidential. So if you were working on, if you were using OpenRouter, right, and you're using Shoots or Targon or 19, the miners are able to read the messages that are being sent to and from there. And so by enabling this, we can start to charge for paid on OpenRouter because we can offer those security guarantees to the clients of OpenRouter. Additionally, when we train our own models, which I'll be getting into in the back half of this novelty, when we start training our own models, whether that's from a person using Targon or it's us or anyone like that, you can do the entire stack or the entire flow entirely confidential, which means that you could train a model on Targon, fine-tune that model on Targon, and then deploy the inference of that model on Targon. And the only place that people could access it is Targon. And so this offers a lot of strengths to the subnet, particularly the economics of the subnet. And so we're really thrilled to be able to release this today. This is about to be merged right after this call. We were going to merge it before the call, but then we realized okay, well, if we merge it and then we need to address something, it would probably better just to merge it afterwards. I wanted to address this because I saw the MUV guys claiming that this is a move to centralization. That's not true at all. Any of the claims that you can make about Targon, the aspects of it that are centralized, you could make about any other subnet. There's a lot of opinions or opinionated design decisions when it comes to subnets. For example, like 256 UIDs, right? You could say that's an opinion or an opinionated design decision, right? And so through these sorts of opinionated design systems, some of the top subnets have these elements of centralization. And, when I started working on Bittensor, close to, 4 years ago, coming up on 5 years ago, one of the real goals was to be able to do the entire stack of training in a decentralized fashion. And with the TVM, we can now do validation on a Raspberry Pi. And so even though we have these opinionated design decisions in there, it doesn't mean that it will be that way in the future on the subnet side, which means that we could enable people all over the world plugging in a Raspberry Pi inside their home and validating the work that is being performed on the subnet. And so that's really exciting because there are other subnets, I would say, that are trying to tackle the holy grail, which is heterogeneous compute over residential internet connections. This is an incredibly noble goal and something that I deeply support. It's not necessarily what we're trying to accomplish here. Rather, we're trying to accomplish the ability to allow for permissionless participation inside of the subnet, but also having enterprise data center grade GPUs to be able to compete head to head with the leading frontier AI labs. So this is OpenAI, xAI, Anthropic. They all have 50,000, 75,000, 100,000 GPUs that they're using to train their models. Unless there is an architectural difference or an architectural improvement, which I'll also be getting into in the latter half of this novelty search, it would be very difficult to compete with the economies of scale that those companies and those frontier labs have reached. Our ambition with Targon, the Targon virtual machine, is to be able to go head to head to go head to head with those frontier AI labs. So there was a lot. We were having a discussion. We've probably talked to every data center under the sun at this point. And it kept on going back. They kept on asking us the same question. Okay, so you have the compute solved, but how are you going to distribute your multi-terabyte size data sets to each of the nodes? And innovations like 3FS from DeepSeek using RDMA are ways that we can accomplish this. But when you are doing cross data center training, it presents, you can't do cross data center training all under a single RDMA network. So as a result of that, you have to have your storage distributed across each of the data centers. And so something that we'll be talking a lot more about going forward in Q2, and we'll have a lot more to talk about at the end of Q2 with our updates, is our progress on being able to do model hosting and dataset hosting as well to support the training efforts that are happening on Targon. So, yesterday it was fully public compute being used from everywhere from RunPod, which is like, Docker-based shell access, all the way to, bare metal. I know that Complex, for example, has bare metal access, is using bare metal. And so today, what we can accomplish is fully private compute, SSH access with bare metal support, so that we can deploy with Kubernetes, we can deploy with, we can just SSH straight in and do use a single node, for example. An example of something I'm really excited to do is support the work that Templar is doing. We supported, we gave them 16 H100s to help them out with their validation or their training. I'm not exactly sure what they were doing with the H100s, but I know they were doing awesome work. Huge fans of Templar. And so, this is something that we're still going to be supporting formalized with going forward. And also being able to host the storage of the data sets and the models themselves, so we don't have to rely on any third parties in order to accomplish our mission. I also wanted to address the incentive transition between Targon v5 and Targon v6. It's going to be a gradual transition. We're not just going to dump this on y'all. We're going to be starting off with the 70-30 split to incentivize bootstrapping these confidential nodes. We want there to be an outsized reward for that so that people are really incentivized to get confidential compute turned on. And we will be annealing down the incentive over 2 weeks from 70-30. And so it'll drop at, I believe, about 2.14% per day. So this way, we will be able to maintain the service that we're still offering on OpenRouter, while also incentivizing the production of these confidential nodes, because it is not a simple task to actually set that up. Getting your miner started once you have set up the TEE and the NVIDIA confidential compute, that's the hard part. And it's very hard to scale that. And so it's something that we're really excited to be able to incentivize, because it's not simply like, oh, you can just plug in, you can go to Latitude or Shadeform or one of these places and just plug in an H200 box. You have to, actually be able to enable confidential compute on there. And so hopefully that we've addressed some of the miners' concerns. We're not trying to throw y'all into the deep end. We wouldn't be able to do this without y'all. It's, sometimes I would say it's a love-hate relationship. Sometimes the miners love us, sometimes the miners hate us. But really at the end of the day, what we're trying to do is advocate and advance Bittensor globally, but also Targon, and to be able to produce the same things that a frontier AI research lab can do. All right. So that's been our updates on what we've done at Manifold. I know that this, I think Jake's probably laughing right now, considering that this next topic that we're going to be delving into is one of the ways in which we're going to be using the TVM. When I was working at OpenTensor, I would do this thing called JEPA pilling people. And hopefully I can JEPA pill all of y'all by the end of the call. I personally think that this is the step function required to take AI to the level of human level thinking. And so I'm really excited to share this with y'all. So, why autoregressive models fail? Fully autoregressive models like ChatGPT, screen got messed up there. They predict each token sequentially. Despite producing impressive and fluent outputs, these models frequently make factual and logical errors. Each mistake compounds as the model continues generating the text, making accurate long-form responses particularly challenging. Now, the limits of autoregressive decoders are that these models follow a fixed computational pathway on the base models and things like that. I'll talk about reasoning models in a second and how those are like, there's two reasons why those don't work. And there's also an interesting reason on why they're being developed. But they limit the ability to actually like think long-term. They can only immediately optimize for the immediate reward at the next step. And so because of this, they are trying to be exactly factual, which makes the model compound and start imagining and hallucinating the outputs, because they don't actually know what they don't know. They're just outputting what is the likelihood of this next token. Now, that in itself is very important, and all models going forward will incorporate autoregressive decoders. But autoregressive decoders are not the end-all be-all, right? So I want to address reasoning models here, because reasoning models like DeepSeek R1 or the OpenAI O1 and O3 models, they attempt to address these shortfalls in autoregressive decoders. So by outputting the larger range of different token possibilities, you're more likely to get the actual true answer in the output of the reasoning model. However, if the model has never encountered something before, it will fail at that task no matter what. It is simply regurgitating its training data. The best way to think of an autoregressive decoder is as a compression algorithm. You're taking a 5-10 terabyte data set and you're compressing that down into a 10 gigabyte, 100 gigabyte, the larger the hyperparameters, the more hyperparameters there are in the model, the larger the model will be. But the efficiency of that compression, is what you can describe as intelligence. Now, this doesn't mean that it's intelligent in the same way that you and I are. It is not intelligent. OpenAI's O3 model is not as smart as my dog Milo if it was put into the real world. Even though Milo lacks the ability of being able to generate natural language, she is able to navigate the world in a way where she doesn't die, right? Like this, humans have to optimize not just for maximizing the reward, but for minimizing the cost in the future. And so humans and animals, are exceptionally intelligent. And the reason why humans and animals are exceptionally intelligent is because they are able to discern the dependencies between the X and the Y. Now, what do I mean by this? I mean this right here that I'm showing you on your screen. This is a snippet from the deep. Oh, did I lose it? No. Okay. I was just making sure I didn't lose y'all. This is an example from the AGI ARC 2 challenge that recently went live. One of our ambitions with the TVM is to be able to win this prize by leveraging JEPA. You see, when humans are able to, everyone I've asked in the office, and I showed it to my wife, and I talked to a lot of people, I show them this picture, and I say, based off of the X and the Y, what is the rule for coloring the boxes, right? Now, very obviously, you can see that the pictures or the coloring is based off of how many holes there are in the actual image, in the actual Y. And even though there are two blank spaces right here, it's still one hole. And so when tested on the ArcAGI 2 task, O3, O1, these models get this question and these types of questions correct 5% of the time. Now, we could just train on the test data set like everyone, like most of the people that are benchmark stat maxing are on Hugging Face and such. But ultimately, how can you create an AI that can do what humans are doing when they look at this and see the dependencies between the X and the Y? The path to intelligence is, the path to, the idea is that it develops an internal model, a world model, and it learns the dependencies between the X input and the Y input. Now, the X input and the Y input could be anything. It could be images, it could be pictures, it could be text, it could be so many things. Now, what the JEPA learns to do is not generate. It does not output text, but rather it learns the dependencies between the X and the Y, and outputs an abstract representation. This abstract representation is in the form of a tensor. And that tensor can then be inserted into an autoregressive decoder to generate outputs based off of that. So if I wanted to train a model that was if I wanted to train a model that was for the robot, right? And so I need to be able to combine all of this sensory data. This is what's known as sensor fusion. I need to be able to combine LiDAR data. I need to be combining 3D depth data. I need to combine inertial measurement unit data. I need to combine all of these different representations of information and then have the JEPA model produce an output or an abstract representation that can then be decoded as torque actuations. This is how we are going to create things like embodied AI. This is how we're going to create artificial superintelligence. Because by scaling these types of models up, we could create a model that is smarter than all humans combined. So by achieving, so this picture that I'm showing you right here is utilizing a JEPA in an agentic fashion. And what I mean by agentic fashion is that you have the action space. So if anyone's ever used OpenAI's RL or RL Gem, you know that you have your observation space and your action space. And then you have your reward function. This is reinforcement learning 101, right? From 2016. What this incorporates as well is a cost function. And what you can do is you can stack these on top of each other. And let's say that each prediction head is measuring a different latency. So let's say that this base layer is 25 milliseconds. And then the next layer is 50 milliseconds. And the next layer is 100 milliseconds. We can minimize the cost at the very top of the network while maximizing the reward at the very next action. This is how humans work. This is how Milo works, my dog. This is how all animals work. Because we have to exist in a world that is cruel, that will kill you for no reason. You'll starve, or you will get too cold, or you'll get too hot. There's this happy medium that animals have to exist in. And because of that, we have to evaluate maximizing the reward at the immediate input and minimizing the cost of our objective function. And so by stacking these on top of each other, we will be able to develop a artificial intelligence that can predict into the future, and it's in its action space, while also minimizing the cost of performing that action so that it doesn't get itself hurt, for example, or doesn't topple over if it's in the robot form. And then be able to distribute this and have it completely confidential on the Targon virtual machine so that the value can remain inside of Bittensor, the value can remain inside of Targon. The only place you'll be able to access this model is on Targon. And so this is how we are able to perform a step function on our current generation of AI to create a next generation AI powered by Bittensor, only on Bittensor, only on Subnet 4, brought to you by Manifold, brought to you by the miners, brought to you by the validators. Thank you very much for listening to my talk. Hopefully you guys are JEPA pilled after this. And thank you very much. All right, let's open this bad boy up to questions.
Thank you, Rob. Holy moly. Can we see some demos of the products here on the screen? Like you went through these announcements really quickly.
Yes, so I can most certainly show you this. I'm gonna log out of my account because I have a lot of accounts labeled right now, and I don't want to dox anyone, including myself. So I'm gonna go ahead and log out right now. And okay, so I'm going to start with Tao.xyz because I love this product. It's something that I have a lot of scripts to do this already with. But now I can do it from my phone, which is great. I'm going to share this window right here. So let me know when you can see my Tao.xyz screen.
All good.
Perfect. So, one of the really awesome things about Tao.xyz is, in my opinion, is that Bloomberg terminal feel. So we wanted you to be able to access everything without having to scroll. I feel like on some of these other websites that we've been using, you have to scroll all the time. I mean, it's slow. It's, you know, it's a pain to navigate, right? So if I want to be able to go to, you know, subnet 18, right? Zeus, even though it says Cortex right there, we're fixing that. We were using the wrong BTCLI set identity thing. This will be improved. It's working on localhost, but not on main. So here we can see Cortex, right? So I'm going to open up the delegations table here really quick. And I want to look at this sandwiches really quick, right? So we can see that this one account right here is doing the sandwiches. I don't know why that busted, but it's good to know. Of course, it always busts when you're trying to do demos. So I can come over here and I can see that this is a mevbot, right? You can see that they've been doing a lot of sandwiches on subnet 84. It allows me to have a really quick glance at everything that's happening inside of Bittensor at this in real time. I want to see who's been selling Cortex. I'm not trying to pick on not Cortex. I'm not trying to pick on Zeus, by the way. I'm actually a big fan of Zeus. I've been DCAing in. That's not financial advice. That's just because I like the weather, and you know, it's going to be cool to be able to predict insurance premiums. Now I can see that. Okay, so we about a couple hours ago we've been having some sales, but I want to see how many I want to see some big transactions, right? So a large transaction that happened is 7 days ago. So large transactions are what, 500 alpha, right? Yeah, so greater than 500 alpha. So then I can go and I can click on this cold key right here, and I can see that they still have 136 Tau balance in subnet 18, but they're also on subnet 14, which I think was just purchased by Fish actually. But I'm not sure. So if I'm wrong on that, forgive me. And so it allows you to really just sit here and watch the chain. It updates in real time. And so instead of having BTCLI ST list open, I can just have this here open right now. I can go to latest, I can go to all events. I can see, who's buying and who's selling. And then also I'm not logged in right now because I have my watch list saturated. But you're able to then star this right here and then give it a label. Now, I'm going to be adding in a feature, or we're going to be adding in a feature to be able to where whenever you have something starred, like and with a unique name, it'll actually show up here in the delegations table. And we will also be changing the this to look at the subnet param and change based off that. So like if you come over here to the subnets tab, you can see the alpha in and alpha out, or the tau in, the alpha in, the alpha out. You'll be able to see all of that. It kind of sucks that it's buried in here right now. I think you actually told me that it's hard to see this right now. So we're going to be adding that in later today. And we've also added analytics. Along with news and these sorts of things, we are updating our validator. Shout out to Swam Nation, okay, for letting us know about the Tao.com validator. It is there right now. Let's hope it stays there and doesn't disappear on us like it has been. And so we can come over here to Targon, for example, and you can see historical alpha price. You can see historical emission. You can see the miners, for example. Registrations, all of these sorts of things that you would be able to see on other providers if you really wanted to dig into it. You can see, for example, validators. So let's go to Tau stats. You can see the alpha staked on each of the subnets. And you can look at latest transactions. So you can see the to and the from addresses. We are going to be adding in transfers here shortly. And also something that our boy here is going to be doing is making the load time from 60 milliseconds down to 6 milliseconds. Before it was taking 50 seconds, and then Josh was like, look at your planet scale calls. And so that's what we've been working on with Tao.xyz. I'm going to go to Targon.com right now. Hopefully I'm not logged in. I am logged in. But this is the new redesign of Targon. It's the Targon.com that you know and love, just with a nice new sleek design on it. One of the critiques that we received a lot last year was that we really focused on our design, not just on our websites, but having a unified design. So utilizing a lot of the similar components that were to really have and nail down a nice user experience and user interface. And so, for example, you can come to the playgrounds. You can get the code to be able to hit this. You can change the different parameters. You can browse the models that are running. So, I mean, wow! Shout out Sauerkon. Shout out the whole Tao.xyz Targon.com team. But not just shout out Sean. Shout out Brigham. Shout out Alan.
Had a great team.
Yo, free my boy. Never mind. Anyways, free my boy TJ. And so we've really spent a lot of time building this out, but there hasn't been a lot of the core functionality change to Targon. Something that we're not going to be doing with the TVM is renting out like bare metal access to these machines. We need to I'll tell you the truth. We talked to a bunch of data centers. We really understood how the unit economics work on how GPU sales work. And reselling compute is not necessarily a great business. It's an inefficient market. And like, for example, how it works right now is you have the data center and they're paying 30 cents an hour, right? That's how much it costs them, right? Maybe they have debt, maybe they don't. I'm going to make an assumption that they paid cash for it, right? So their operating cost is 30 cents an hour. They're going to go to a broker and they're going to sell that for $2 an hour. And then that broker is going to turn around and sell it for, on demand, or maybe sell it to another broker or something like that for $3 an hour. And then they're going to sell it one more time for $4 an hour. And so there's so many people in the loop here, all taking a cut. There's no way that this maintains itself. And also, your margins are like fixed at 10, 15%. If we really want Bittensor to work, if we really want Targon to work, we need to be doing things that are going to be returning multiples on the investment. And so this is why we're heavily investing into AI training. This is why we're really speccing into inference and doing confidential compute so that we can charge on OpenRouter and other websites like Hugging Face endpoints in these places to be able to offer, SLA uptimes, offer, really good quality controls. Another example is something that on Targon.com, or not Targon.com, on Dippy, being able to offer them confidential, secure compute. So, this is what we've done on Targon. Now I'm going to take it over here to Sybil.com. So now you can access R1 and V3 with this brand new redesign. Let's find out how tall a cow is. Our search results are much faster than they were before. You can see that it's been, it's generating quickly. We are using a different node cluster for this right now than Targon.com, just because we were testing it. We're going to be, since we just launched Targon.com back online, we're going to move it's simple. It's just one line code change. And so, so this is Sybil.com. And so these are all the products that we released over this past week, and we're really proud of it. And so, if anyone has any questions, the wallet. Well, I can't show the wallet because I have my wallet stuff in there.
That's fair.
We can't do a demo of the wallet because I don't want to dox one of my wallets. And so,
where could we find the wallet if you were looking for it?
You would go on the Google Chrome store.
Look it up on your.
Yeah. Here, Tao.xyz. I don't know if it's gonna be
I don't know if it'll find it.
it'll be indexed yet, but yeah. So it's not there, but there are Bittensor wallets.
There it is. They've put it in the chat.
Yeah, and so
On Firefox as well.
it's also available on Firefox in their store.
Yep.
Yeah, so it's available in their store, and so yeah, so these are all the different things. Please use it. Please let us know what you think. If there's things that you want to add, improve, these sorts of things, that'd be great. So, thank you.
Thank you, Rob. Fantastic. This is, I believe, the second extension that is specifically designed for Bittensor, correct? There's OTFs and there's this. Is there any other?
I think Talisman is another good example of it. Polkadot.js also technically works. It just doesn't support the hotkey, cold key stuff, but like you could technically use the Polkadot.js wallet. Any wallet that's compatible with Polkadot.js, the actual library itself, supports Bittensor. We just wanted to there were some certain things that we wanted to add, like for example, like transfers, like really dedicated to the core of the DTAO system. And so, yeah.
Beautiful. So let's hear more about the subnet overhaul. So you're introducing confidential computing onto subnet 4. And if I understand correctly, it means that the validators just check proofs.
Correct.
And that's why you can do it on a Raspberry Pi. The validation is effectively free.
Correct.
Still the case that as a validator, I have stake on the subnet that I can send off jobs to these miners and have them do effectively arbitrary computation?
Correct.
And so on subnet 4, you guys can just switch the back end here, but still do all of the inferencing that you're doing today, right? So Targon Hub doesn't go down, nothing changes, even though you've changed from a pure speed-based validation system. You're now able to do speed on anything, really. It's like any type of computation that you want. And that makes it much more versatile. And as you said, it allows you to do your own training runs. So you guys want to train a machine learning model. So having access to the owner key on the subnet and having one of the biggest validators will allow you guys to coordinate these machines. And then you started talking about storage. And I'm actually really curious about, how does that work in this trusted computational environment? Can you do confidential computing around data sets that are shared in this peer-to-peer network? Like you were speaking about this, but you sort of skipped over it, Rob. Can you talk more?
Yeah. So what in particular I was like talking about was so because these data sets are very like the first model that we're going to train is at 32 billion. The second model that we're going to train is probably about 150 to 200 billion hyperparameter model, and then we'll train about like an 800 billion hyperparameter model. The data sets and the model itself will be terabytes large, right? Like huge, like massive. So how do you move that data from one place to another, right? Like, because somewhat, like for example, complex, or maybe I shouldn't say complex, miners, right, are going to have their data centers, and we can measure things like if you're using RDMA, we can measure like all of we can measure the exact CPU type that you're using and know how much, like what the performance of that's going to be, all of these sorts of things, right? So you have a data center in the Netherlands, then you have another data center in Dallas, and you have a third data center in Japan. You need to be moving terabytes of data between these different places, and in order to actually be able to do this sort of training, right? This is very difficult.
Don't you mean that you're sending the model weights, because the data set doesn't necessarily need to be transferred between nodes? I'm not sure I've ever heard that.
Not during the training run, but what I mean is that the data set will have to live in all three places, right? So it'll have to live in Japan, it'll have to live in Dallas, it'll have to be in each of those clusters that the miners are providing. And so the issue, because we can use a lot of optimizations for cross DC training, like when we don't actually even need to send the model weights necessarily. It's like we need to send the steps and things like that, right? But the actual like models themselves, and the hosting of those models, like the actual model weights, they have to be moved around from one miner to another. And so if a miner comes online or another miner goes offline, we have to have that data redundant. Do you see what I mean?
More or less.
So what I was talking about with the storage is that we'll be able to offer a storage solution that's also fully encrypted, fully private, fully confidential, for specifically AI workloads, at the terabyte level, without having to do, like ZK type stuff. You know what I mean?
Right. And
So
and
it's mainly to solve some of the challenges that we will have when we're training models.
I mean, this is incredible. The ability to have to verify that people are doing much more complex forms of computation, storage, you name it, on the machine. And my question, I think this is probably a question from the crowd as well, is if the validation is so strict on a miner, meaning that they must run a particular type of hardware, where is the innovation that a miner can push into? And does that limit like the ability for the network's incentive mechanism to truly extract value? And have you thought about that? And like, what's your take?
So I really have thought about it. I do eventually want to bring back competitions on top of confidential compute. I think so like how I'm just kind of thinking about it right now is that like, okay, you would put your node you would verify your node. So like you would sign up your miner node, you would put it on the network, it would pass attestation, you would be sent the confidential virtual machine, and then you go into the confidential virtual machine. And then from there, once you have performed or you would develop your own confidential virtual machine, like your own binary, and then that would be sent to the actual nodes themselves. So if you're doing something nefarious or anything like that, it's very easy to kill, but then we can actually start competing again. Now, because we are transitioning and we're in like this transition phase, we need to be able to make sure that we don't create too much volatility that it disrupts the existing Targon.com service. And so right now we're just incentivizing people to put those nodes on there because it is very hard to actually have a node that runs CC to begin with. And so because of that, like there's a lot of sophistication and requirements to actually enable and to have it pass attestation. So that in itself, I would say, is where a lot of, where the initial innovation is going to come in. But then past that, we can start doing competitions again to really supercharge using the incentive mechanism. My CTO, Mr. Brown, would like to say something here.
Yeah, I think another another, I guess, plane you could say miners can now compete on is the CVM requires you to run confidential compute, right? But we only restrict on like the GPUs that you're using and the CPU so much that they're able to run confidential compute. Now, that means that there's a lot of axioms here that we're able to measure and verify, while also not restricting. So, for instance, say I have an 8x H200, right? And I put that on Targon as a CVM, whatever. We can see, okay, how fast is your storage? How fast is your latency between your nodes? Yada, yada. And this almost becomes hardware optimization instead of software optimization, where we can say, hey, if you have 8 clusters, so like 8x H200s, and we see that you have like top tier InfiniBand going across all of them, you have shared storage across that we can access, all this sort of stuff, we can start seeing these things and start incentivizing them. So again, you can almost think of it as we're incentivizing hardware level optimizations instead of software level optimizations. There's a whole domain there we can play with in terms of what we reward.
Yeah, it is. I mean, after this experience, I mean, the depth and the expertise required in order to actually do something like this feasibly at scale is in itself something that the incentive mechanism is going to be really great for, or like really geared for, because instead, like Josh said, instead of it being a software optimization, we can actually incentivize the smartest people in the world at creating these clusters to put their clusters on Bittensor. Do you see what I mean?
Yes, I do. And so there's an expertise in understanding how to do confidential computing on GPUs across clusters with 10 or 20 or 30 GPUs all behind a single node. That's not easy. And getting that to work is worthy of incentive. And if
Correct.
you can get it done, then perhaps you have the largest like stitched together confidential computing system in the world. So you have the most number of machines underneath your fingertips. I mean, and one thing here that I think is really interesting and can't be understated is just that before we did confidential computing on subnets like 4 and 64, there was no way for you to go to an enterprise and say, "Hey, use this system. It's cheaper. It's faster." Because they're just going to go, "Well, I this private information in my data set, I can't post that out to a group of random miners." With CC enabled, or TE, what they're doing on Targon on Shoots, pardon me, you can actually go a step further and not only say, "Hey, like this is encrypted, like this is private," but those other guys that you're just trusting, like OpenAI, you're actually just trusting them. We
Yes.
can prove that your data is not being used. We can prove that your data is private. Don't trust, verify, and at the same time, do it potentially faster. And I'm assuming there's some overhead here for TE and CC. So like, what does that look like? Like, are we going to go down underneath other providers in terms of inference speed once this is pushed? Is that sort of like the initial expectation?
Maybe potentially. I mean, it depends on how we set up the inference nodes that are running inside of the TVM, and it also depends on what hardware they give us, right? So if a bunch of our miners, if it's easier for them to access H100s, then we have H100s first, and that's just what the miners are giving us. And then we incentivize H200s, and now we have H200s we can run nodes on and increase our speeds. We've seen a lot of innovation from our miners in terms of increasing their speeds in the V5 version. But as we've been working on this V5 version for months now, you start getting into this weird problem where if you provide open access or some sort of access to these miners, right? Like we want OpenRouter to be able to send us requests and those go to miners. You need to be able to incentivize those miners to handle a large amount of requests. And at the same time, it's not possible to block those miners from also sending queries. And so you get into this almost chicken and the egg problem of how do you make sure that miners are actually handling that amount of compute that's coming from real users when the miners could be users themselves sending like what we've seen recently. They'll just spam the endpoints with their own requests that they already have cached. And there's not a good way to solve this. And especially not a good way to solve this efficiently, where validators don't require massive GPU clusters to verify log probs and all that sort of stuff. And even with the current clusters that we have set up, it is not only ridiculously expensive to do this, but very slow. Like we're only able to handle a couple hundred, maybe 200 requests every interval. And we're getting up, I mean, we're doing like 10 billion tokens a day. Combined from OpenRouter usage, along with however the miners are spamming our network. And so what we've been hearing a lot from the people that we've been providing Targon Hub to is, look, speed is fast, speed is great, but I'd rather have way lower speed for privacy. And another huge thing is like, if I send a request through, say I'm role playing, and I get a response, and I don't really like that response, and I want to re-roll it, it's very, very hard, even with the verification mechanism we have now, to ensure that something's been re-rolled and it was re-rolled properly and the temperature was respected, all these little parameters were respected without also massively damaging TPS and again requiring these very, very large rigs. And so most of these people we've been talking to are like, look, we don't really care about speed. We want consistency. We want privacy. We want like if I re-roll something, I want to actually re-roll. I want to respect all these parameters. And so if we actually own the confidential compute, we actually own the miners are giving us this hardware to run it. We believe it's way, way more beneficial to everyone using the service that it's cheaper, secure, private, faster, and is actually doing what you want it to do. And again, that's why we want to move the incentive mechanism away from something that people aren't asking for necessarily, being speed, and moving it to security, moving it to optimizing your actual hardware layer, that sort of stuff.
Interesting. And what you've described in this call is that you can go up a level now in terms of what you're building on Subnet 4. Not only can you do inferences, but your intention is to focus on actually cross data center training, cross internet training. You're going to work on JEPA. A bit about that, Rob. I looked it up on the call. There's not that much research going on JEPA right now. Is it a dead project, or are you just Yan LeCun fanboy forever? You're going to chase him to the grave? But it doesn't really matter. Yeah. I guess this is just an attempt, but you can train any model.
Yeah, we could. So the first models that we'll train are like regular autoregressive models, right? Like the 32 billion. We'll train our own version of R1 V3, and that will be only available on Targon. And so this is, I think, a really great way for us to be able to not only attract, like, not only for Targon to build a moat, but also to be able to attract a new class of people that are using AI every day that maybe don't want to use or are unfamiliar with Bittensor or turned off by crypto. And we can really build something that can scale to millions of people who know nothing about what's going on under the hood, other than that the work that is being done on Targon is incredibly valuable because they can access it. It's the only place they can access it. And so when it comes to JEPA, one of the great things about Targon V6 is it makes it to where it's like we basically are unstoppable at this point. Like it will be very hard to stop us once we have Targon V6 going. You won't be able to exploit it. It's cryptographically secure. Like whenever you see these things all the time, and it drives me up the wall because like you'll see like private inference, right? But it's not private inference at all. Like it's really not. Even if you're running it in a data center that's HIPAA compliant, you can still see the logs. Even if you turn the logs off, you can do a man-in-the-middle proxy between you can sit in the middle and capture all of that traffic. I know that for certain. And so I won't say how, but I know that for certain. And so by having something that's truly secure, what I think is going to be amazing is that like we're actually building something that's so valuable that what I foresee happening in the future is the way that delegated stake. I texted you this the other day. Delegated stake was one of the greatest mistakes on Bittensor, and the reason why is because the thing that I'm worried about now is like, okay, now we've created something so valuable, something that like companies, very large companies, that will want to be able to access something like this, right? They want to be able to access a global data center infrastructure with RDMA, the same high-level quality data centers that OpenAI, xAI, Anthropic are using. And so they're going to want to be able to tap into that. And so they're going to start purchasing alpha to take over the subnet, like to be able to have the most bandwidth to the miners. This is the thing that like now what are the security concerns I have today or going forward is that, right? Like, okay, now that Now we can't sell our alpha at all ever, because if we even sell a little bit of alpha, someone's going to come right in and then take it over. And now they're going to be able to have access to 20,000 H200s that are running on the subnet, because we can monetize TVM in a plethora of ways and immediately insert it back into the subnet, like automatically. And so I'm really excited about this, and I'm really excited about the work we're going to be able to do in Q2, because we're going to be able to extend, or to be not only to extend our lead, inside, but also on the outside, be able to catch up to these people that are actually the number one winners right now, which is OpenAI, Anthropic, DeepSeek. We'll be able to catch up to them this quarter and then pass them in Q3 with Jeppa.
Where do you see yourself directly monetizing bandwidth on the subnet? Like, who do you go to first, Rob?
Well, so the first thing that we're going to be able to do is next week, we're going to be able to turn on paid on OpenRouter, because we'll have confidential computing, and we can know. So like the things that people are paying for, we can with certainty tell people that this is the only place you can get true private inference, where we've thought of all of the different ways you could break in. Like, we've really considered a lot of it. And so I think that in itself is a great selling point, right? I was talking to my elderly father about it last night, and he was blown away. He was like, yeah, because, this is the reason why he doesn't want to use OpenAI, is because he doesn't want to talk to it, because he doesn't know who's going to be able to read these messages. Most people out there in the world today don't want to use AI because of this, or at least cloud providing. This is why everyone wants to run those models locally. So how can you get DeepSeek R1 at home? If you go on Reddit, if you go on Twitter, there's a lot of projects. Exascale AI, for example, that's something that, they all want to be able to run it at home, so that OpenAI or any of these people can't read your chats. Now we can offer it in the cloud and no one can read our chats. So we'll be able to turn on monetization on OpenRouter next week. But beyond that, right, by having our own private models that we've trained and we've done the entire loop inside of Targon, we'll be able to retain all the value that generates inside of Targon. And I think that that's where a lot of the value creation is going to come from, not just from the inferencing, but from the exclusivity. I'll give you. I think of subnets that are selling inference right now, like Coke and Pepsi. And what we're essentially doing right now is we're like local bottlers. So we are bottling up Coke and Pepsi soda and then distributing it to all the stores in town. We want to make our own flavor of models. We want to make our own flavors and sell our own flavors and keep that inside of Targon. And so that's really the next step for us, to be able to really be able to maximize the value that's being generated from Targon. And I think that we'll be, I know we'll be successful at that.
So you'll be able to turn confidential inferences. And how do you stop man-in-the-middle attacks here between you and OpenRouter and the validator and the miner? Like, how does that process work?
So there can be a man-in-the-middle attack between OpenRouter and the Targon Hub API. That is true. So you could be, because unless it's encrypted between OpenRouter and the Targon Hub API, which I think it is. I mean, it's going over HTTPS, so that would stop most man-in-the-middle attacks, right? But we wouldn't be able to stop the OpenRouter side, obviously. Right. Now, I don't think that OpenRouter is going to be saving that data, for example. I mean, in fact, they have a flag that you can enable that says we won't train on your data. And so if we enable that flag on OpenRouter, I don't think they're going to log anything. In fact, when we spoke to them about getting on the service, this was something they asked us. You're not saving these requests, right? And so, but technically, you could sit in between the Targon Hub API and OpenRouter and do that. But if you went directly to Targon.com, then we can really, for sure, because at every step that we can see that, so we can really ensure that it is private and fully encrypted.
How do you ensure that? How do we ensure that Targon Hub is not saving the data?
Well, so that's a good question. That's something for us to consider, actually. How can we prove that cryptographically. I'm sure there's a way we can prove it cryptographically. Because I think that the days of trust, right? Like we're going to trust these people is over, right? Because now we can cryptographically prove that the inference was run. We can cryptographically prove that the environment that it was run in was secure. And so there's no reason why we couldn't cryptographically prove that Targon Hub didn't save that either.
Beautiful. Inference is really just low-hanging fruit. You can do anything with this computation.
Especially when we make JEPA, and it's a STEM function in AI, and now we've created an artificial intelligence that's smarter than all humans combined. I'm just going to ask JEPA to make me money. Like, you know what I mean? Like, I'm going to say to JEPA, hey, build yourself a robot body. Okay, now what I want you to do is I want you to go to Bastrop and build me a steel plant, which is a primary product, right? Or I guess it's not. Yeah, it's a primary product. So then it's going to start manufacturing steel. Then I'm going to say, start making copper wire. Okay, so now start making USB-C cables. Now start making yada, yada, yada. If you look at the regulatory macro environment in the United States right now, we are being incentivized to start manufacturing here in the United States. And if I have a super intelligent AI, I can just tell it, manufacture me everything, and it will. That is what we're doing on Targon. Now, you may or may not believe me, and I believe that that is the way that you should approach it, right? Don't trust, verify. I'm telling you that this is what we're going to do. In 3 to 6 months, we're going to have, each quarter we're going to release a progress report, and that's what we're going to accomplish. Because think about it, right? I mean, Jake, I was the first person here in Bittensor, right? Look at what we've accomplished together, right? I'm telling you right now that this is what we're going to accomplish. And I've been working towards JEPA for a very long time. And now with TVM, I finally have the compute to be able to pull it off. I mean, this is what they call it? I learned what they called it, like Liberation Day or something yesterday or something like that. Yo, this is our Liberation Day. This is the Targon Liberation Day. We're storming the beaches at Normandy, okay? That's what we're doing right now, and no one's going to be able to stop us.
Connotations right now. Rob, is it possible, one of the issues with people running validators on say, other compute providers on Bittensor is that they're worried about their keys leaking, things like that. That might be low-hanging fruit. Is that possible? To just go to...
You can mine every other subnet using TVM. Yeah.
Great. And you have a validator coming along. All right. So
yeah, you see what I was saying? I told you, it's like people are gonna start making validators when they realize this.
All right. So that's it from me in the way of questions, but I'm sure there are other people in the chat here that maybe want to jump on stage if you guys are willing to host them.
Yeah. I see from Fish, a Targon fan, as he said in the chat today. Can you please clarify how to get access to the compute? We're going to be having an SDK coming out very shortly. Once we have CVM, once we can compile the CVM for you, then send that out to the miners, then we'll be able to pass out the SDK. So that should be coming in about a week or two. So stay tuned on that. You can still access the inference right now, but you'll need to be able to compile the CVM, which in itself is not a trivial task. But we will have that in 6.1. Yeah, you can. The payment will be through Targon.com. Correct. And you're not renting the machine from Manifold. You're making what, like a Docker essentially? You're making like a Docker image or something like this, right? And then that gets compiled or baked into the CVM, and then that gets sent to the miner, and then the miner runs the CVM. I'm pretty sure that's how the flow works, right? Yeah.
Can you like SSH into a machine here and use it and just run anything? Like, I would like to take one of these machines, and if so, how do you validate that on the validator side?
Yeah, so what we're validating is what uptime, that the machine stays online, the number of GPUs that they're running, and their attestation report, which comes from a specialized chip in the actual computer. So even if you owned the machine, you couldn't break in.
So that means that you can't SSH into the machines directly. You can just say, "Hey, run this script," but I can't, as a user, SSH into the H100 and run my
Yes.
arbitrary.
So
But
technically, if you made a CVM that you wanted to SSH into, it would be a virtual machine that you were SSHing into, not a Docker image per se. Now, when I say Docker, I'm saying you should think about it in the same way that you would build a Docker image. Like like when you have a Docker image, like you're like compiling your entire file structure with the operating system and everything. Like that same process is what you're doing for CVM. And so you can run it in. So like if you have a Kubernetes CVM, then you can, deploy a Kubernetes cluster over. So this is how we'll do the inference, for example. So you technically could SSH in, and it would be better than SSHing into a Docker, if I'm not mistaken.
Yes.
Yeah, it wouldn't be like you could run, like you could SSH in and run your own Docker and everything like that.
you could do that.
Mm-hmm.
And so go on.
The CVM itself is a full virtual machine. Docker is like a mini virtual machine, kind of, where it's like you're running with kubes, it's super lightweight, yada yada. These are entire operating systems that are like just a virtual machine that lives on the bare metal, as if it was like the full OS, if that makes sense. So the idea would be, if you wanted to, if another validator had a lot of stake, then they could tell miners to run their CVM, and then everybody, no matter what CVM is running, as long as it's part of the base CVM that we've created, any validator can verify that, okay, this is a CVM running on this machine. And so the idea is, instead of creating a Docker image, you create the CVM. And now, if you are the creator of the CVM as a validator, you can pre-bake your SSH keys into it. And the miners are always reporting what IP addresses they have all the CVMs for. And so you just find what CVMs are yours, and now you can SSH into those machines. Now, that also means that it would take away from the other, like, now that's just your machine. Now no one else has that machine. And so this is part of what we're going to be playing with and figuring out how exactly it's going to look and map this out. But that is like the domain of possibilities for what we can do.
So you would bake your SSH key into this CVM, throw it over to a machine. Now, from another computer somewhere else, you could SSH into that machine because it has, you have your key in the authorized keys. At the same time, a validator can query this machine and be like, "Hey, are you running this thing that I told you to run?"
Without needing the SSH keys, correct?
And so it doesn't interrupt the session that the other person. So I could throw in your key for you, Josh, and you can use it, but I can just check to see that the thing is running on the machine. And when I check that they're running that CVM, it's a cryptographic proof that they have available in H100. It's cryptographic proof that they have this much RAM. All of the resources available to that that virtual machine, I suppose, is wrapped up inside that proof?
Yeah, so we have the reason we're so confident on the security of this is we have full guarantees from every CPU provider that supports CVM, and NVIDIA themselves have guaranteed that this is secure down to the keys are literally like essentially soldered into the actual hardware itself, and you cannot get them out, and you can only get them through this like CVM process. And so because of that, because it's baked into the CPU, because it's baked into the GPU, those things can securely get the information for all of those different parts.
I see. So if you were to query this CVM as a validator, you can be like, "Hey, do an NVIDIA SMI. Get me the machines that are inside a CVM."
We could make it that way. Essentially, that's almost what's happening. Not quite. It's using a different type of API. We have a pre-built HTTP server that lives as a daemon inside the CVM, and that's what's giving it's called an attestation report, and that's essentially a massive list of all the GPUs, the CPU, all their specs on everything, like all the data we can pull out from this machine. We're pulling out and sending and specifically signing via this encryption method that NVIDIA and Intel and AMD have all guaranteed is very secure. And then that's what's getting sent out. So you're not sending the validators aren't sending like, hey, run this thing. They're saying, hey, give me an attestation report. They're saying, give me this specific report, and then you can go verify that.
And can the miner here use the H100 that is connected into this CVM?
No, the miners would not have SSH access or be able to get into it in any capacity.
Wow, so it actually firewalls the machine off to them.
Yeah.
Yep.
Like it's a full transfer of that's incredible.
Yeah, TVM baby.
Wow.
Manifold. Woo!
Has this been done? Has this been used elsewhere?
Not at scale in any capacity. We actually worked with like actual top level NVIDIA engineers to make this.
This is state of the art.
Yeah.
I mean, this is why TVM is so big. This is why we said think bigger, because think about all the things we can do with our state of the art technology.
Yeah,
Wow.
This is going to be probably one of the first times this is actually deployed at scale. I mean, we're talking with all these data providers or data center providers trying to figure out who can actually serve some of this stuff. And we're very quickly realizing a lot of them have the capabilities to serve it. No one's even tried or had a request to do this before. And so we're actively getting these big data centers like Google, DigitalOcean, all these sorts of people to start enabling confidential compute on their data centers.
Incredible, guys. It's so much fun to be up on stage here with teams like yourselves, where I'm just like, am I talking to a completely new cryptocurrency that doesn't exist inside the Bittensor ecosystem? Like, is this another top 100 cryptocurrency? It really should be. Like, this is so brilliant. And you guys are really the tip of the spear here for making this be a reality. Wow, congratulations. Speaking with the guys at NVIDIA, wow.
Yeah, I mean, we worked on this for a long time. I mean, we had these people in our chat for weeks, just like lambasting us. I mean, dude, they were literally like, your code's terrible and all this stuff. It's like, I can't wait to drop TVM.
That's another thing that I think is a very overlooked part of this transition is when you're trying to do something like verifying raw outputs, or the more how do I phrase this? The more room there is for miner edge on the software level, your verification complexity goes through the roof. At least for inference, and without taking like massive TPS hits by doing zk-ML or that sort of stuff. And we just found very quickly we're spending like 90% of our time just fixing incentive mechanisms for like TPS for the sake of TPS, instead of actually listening to what our customers wanted, which was, like I said, security, all this sort of stuff. It's like, why are we running in circles trying to patch all these million different things that these people aren't really even asking for? And so we started looking back and saying, okay, let's kind of start from ground zero. How can we make an environment where we can really give privacy, we can really give security, we can give exactly what our customers are asking for, and we landed on this.
Pack it up, folks. We can write all of the incentive mechanisms on Bittensor just on Subnet 4.
Yeah, think bigger, bro. Think bigger.
I think that there's I actually believe that will be possible, which is incredible. The ability to write every incentive mechanism on Bittensor into Subnet 4. But that doesn't mean that the individual subnet mechanisms don't need to exist for exactly the point that I made earlier of like, when you collapse the degrees of freedom, when you do pure verification, it also limits what can be innovated. For things that don't need innovation, we can actually collapse them here, and it makes total sense. You guys can do, really you've blasted through to the other side in terms of what we can verify and validate. Really cryptographically from the ground up, which is insane. And we've just given Rob an incredible amount of power, so everyone should be very worried. Bit of a backstory. Rob once told me that he had a lot of Tao, and that he controlled me. So that's why when DTAO launched, I became the largest whale on Subnet 4 so that I could control Rob. So anyways, Rob,
But
don't.
now you control. Now you'll have access to like premium hardware, data center, RDMA. You can like the sky's the limit, man. So actually, you trying to get one up on me, was actually very beneficial for you.
Mutually assured destruction.
Exactly. I mean, I'm not dead.
Okay, guys. Well, that's it for me. I think that's a great note to end on. It's been an hour and 22 minutes here. Fantastic presentation. Really excited. I mean, like the little things just on the side, the Tao.xyz looking fabulous. You didn't even really do a demo in Sybil, but that's like something that's been around for a while and coming back into the limelight. And then the new extension you just kind of threw off the cuff there. Incredible work, guys. What a release. What a week for you guys. And yeah, hopefully we see you in a couple months for Q2 with Manifold Labs. Thanks everyone for coming. See you next week. Ciao, y'all. Bye.
Ciao.